Hello my friends out there, welcome once again to my channel. I remain Dr. D.I. June, your chemistry lecturer on social media. We have been discussing properties of radiation, and we said that when a radioactive element is subjected to electric field and magnetic field, three different types of rays or radiations have been emitted. And we said they are alpha radiation, we have the beta radiation, and the gamma radiation. The last one we treated was on beta radiation, or the beta rays. So we are on the last one, which is the gamma rays, or gamma radiation. Now, gamma radiation can also be described as a gamma decay, and it is usually accompanied by the emission of alpha and beta particles. Look at this now. In the alpha radiation, or in the beta radiation, we have negatively charged particles, while on the alpha radiation, we have the positively charged particles. But now in this gamma radiation, we're not saying that it is the emission of the addition of both negatively charged particles and positively charged particles. Now look at what I said. He said gamma decay or gamma radiation is what? Usually accompanied by the emission, the giving out, or the production of what? Alpha and beta particles. Now this occurs in what? Nuclear reaction. We'll go to that in our later lectures. Nuclear reactions, in which the nucleus is in an excited state. Now remember, the nucleus of every atom is composed of two particles, the protons and the neutrons. And because the neutrons have no charges, the nucleus is always positively charged at all times. Now, when the neutron is now involved in a reaction, we know that the nuclear reaction has taken place, and the nucleus becomes what? Excited. In other words, it's in a state of action. It's not in the ground state. For the excited nucleus to go back to the ground state, it releases what? Its excess energy in the form of what? Gamma rays. Do you see now? When the nucleus is involved in a reaction, it's in a excited state. Now, for it to go back to ground state at rest, it has to emit or release some excess energy that was in it, and that results in the given of what? Gamma rays. So gamma rays also have some properties, as we saw in the alpha and the beta. One of the properties is what? Gamma rays are made up of electromagnetic waves, such as what? X-ray and light rays. X-rays in the hospitals, or when there are compound fractures, we use X-rays to look into or diagnose and then see exactly what is wrong with the bone, and then what involve treatment. Then number two, they are least ionizing. That means to remove any of the electrons from its position, it requires less amount of energy. Then it is also most penetrating than the other two of the radiations. Three, gamma rays are not deflected by any direction, whether negatively charged or positively charged. So the gamma rays are said to be neutral. They are diffracted by a crystal lattice. What is diffraction? When a ray passes through a prism, the rays are diffracted. Diffracted, in other words, means that they are dispersed. They are spread out in form of a beam of ray. And that can lead to what is called spectrum of light. Number five, they are neutral in charge and have no mass. Electrons have a mass. Neutrons have mass. Protons have mass, but neutrons have no mass and they have no charge. So these are certain properties of the gamma rays. So in a nutshell, in totality, a radioactive element undergoes radioactivity by emitting alpha particles. And under magnetic field and electric field, when it's subjected to, three different types of rays are given off, and they are the alpha, the beta, and the gamma rays. Thank you very much. Please comment. Also, share this video. And then follow me on my channel for more lectures. Thank you.